High on the Tibetan plateau, closer to the sky than almost anywhere else on Earth, a great river begins its long journey. This is the Yarlung Tsangpo. It is the world's highest major river, flowing at an average height of 4,000 meters above the sea. For much of its course, it moves gently through a vast, cold landscape. But this calm beginning hides the immense power that the river will soon unleash. This river is a source of life, a force of nature, and now it is set to become the site of one of humanity's most ambitious and controversial engineering projects. A new mega dam is planned here, a project that promises immense power but also carries great risks for the people and nature that depend on this mighty waterway. This river does not belong to one country alone. It is a shared treasure, flowing across borders and connecting diverse cultures and ecosystems. After leaving China, the Yarlung Tsangpo travels into India, where its name changes to the Brahmaputra. Here, it becomes a wide, braiding river, a lifeline for millions of people. It continues its journey south into Bangladesh, where it is known as the Jamuna, before finally merging with other rivers and emptying into the Bay of Bengal. The story of this river is a story of connection, a continuous flow of water that sustains life across a vast part of Asia. The new dam threatens to alter this ancient story forever. The plan to build a dam here is not just about creating electricity. It is about harnessing one of the most powerful natural forces on the planet. The location chosen for this dam is a place of incredible drama. It is a spot where the river takes a sharp, hairpin turn, a place known as the Great Bend. Here, the water plunges from the high plateau, creating a canyon so deep and so long that it dwarfs all others. It is in this remote and wild corner of the world that China intends to build a structure that will change the map of Asia, for better or for worse, and rewrite the future of this extraordinary river. For centuries, this part of the river was a mystery. Its connection to the Brahmaputra was only confirmed by explorers just over 100 years ago. The canyon it carves is so treacherous, it has been called the Everest of rivers, a challenge that only the most daring adventurers have overcome. Now, this wild place is about to be tamed. The Chinese government has approved a project that will place a massive barrier across this waterway. The decision has sent ripples of concern downstream, where hundreds of millions of people look to the river's daily flow for their survival. It is a monumental plan, with consequences that will be felt for generations. To understand the sheer ambition of this project, we can compare it to something already built. Many of us have heard of China's Three Gorges Dam. When it was completed, it was the largest power station in the world, a colossal structure that cost over $30 billion. It produces enough electricity to power an entire country, like the Netherlands. Yet, the new dam planned for the Yarlung Tsangpo is designed to be far, far bigger. It is a project on a scale that is difficult to comprehend, a true giant of engineering. The cost is projected to be around $137 billion US, more than 4 times that of the Three Gorges Dam. The amount of power this new dam could generate is staggering. It is designed to produce 300 billion kilowatt hours of electricity every year. That is roughly 3 times the output of the Three Gorges Dam. To put that into perspective, this single dam could generate enough electricity to power all of modern-day Germany. For China, a country with enormous energy needs, this represents a huge step towards its goals. This single project could satisfy nearly 8% of the nation's current electricity demand. It is a testament to both the power of the river and the scale of human ambition to harness it. The dam itself will be a high wall of concrete and steel, built at the very beginning of the river's Great Bend, near a town called P. This structure will hold back the waters of the Yarlung Tsangpo, creating a vast reservoir in the high-altitude landscape of Tibet. Building such a dam in this remote location presents incredible challenges. The area is isolated, and until 2013, the nearest county was not even connected by a proper all-weather road. A massive effort will be required just to bring the workers, materials, and heavy machinery needed to construct this modern wonder in one of the world's wildest places. The project is not just a single dam. It is a whole system designed to capture the river's energy in the most dramatic way possible. The plan goes beyond simply blocking the river. It involves diverting a massive amount of water through the heart of a mountain. This complex engineering feat is what will allow the project to generate so much power. It turns the river's natural, steep descent into a controlled, power-generating waterfall hidden inside the earth. The scale of this undertaking reflects a new era of megaprojects, where nations are willing to invest enormous sums to reshape the natural world for their own needs. The true genius, and perhaps the greatest risk, of this project lies not just in the dam itself, but in what happens next. The plan is to divert a significant portion of the river's flow away from its natural course. To do this, engineers will drill at least 3 enormous tunnels directly through the mountains. Each tunnel will be about 13 meters in diameter, wide enough to drive several buses through, side by side. These tunnels will run for an astonishing 34 kilometers, burrowing deep beneath the mighty Mount Namcha Barwa, one of the highest unclimbed mountains in the world. This is not simply digging, it is replumbing a force of nature. These tunnels are designed to create an artificial shortcut for the river. In its natural path through the Great Bend, the river drops over 2,000 meters in altitude, but it takes about 160 kilometers to do so. The tunnels will channel the water to a point where it can make a much more direct and much steeper descent. The water will be sent plunging down a vertical drop of nearly 2,400 meters. This is like creating a waterfall taller than 7 Eiffel Towers stacked on top of one another. It is this incredible drop, known as the head, that will give the water the immense force needed to generate such a vast amount of electricity. At the bottom of this massive drop, the water will rush into a powerhouse built deep within the mountain. Here, the force of the falling water will spin giant turbines, the machines that convert the energy of moving water into electricity. After passing through the turbines, the water will be released back into the river system, rejoining the main channel further downstream. The entire process is a monumental feat of hydraulic engineering, designed to squeeze every possible watt of energy from the river's descent. It is a powerful example of how humans can manipulate the landscape to serve their needs, turning a mountain into a giant power conduit. However, this diversion of water is a major point of concern for countries downstream. By taking water out of the river for 34 kilometers, the natural flow will be dramatically altered in that section of the canyon. While the water is returned to the river, the ability to control when and how much water flows through these tunnels gives China a powerful lever. During dry seasons, this control could be critical. The project is a marvel of modern engineering, but it also creates a new and complex relationship between the nations that share this vital river, a relationship based on technology, trust, and the control of water. The location chosen for this dam is no ordinary place. It is one of the most geographically spectacular and extreme environments on our planet. The Yarlung Tsangpo Great Bend is where the river, after flowing east across Tibet, makes an incredible U-turn around the towering peaks of Namcha Barwa and Gyalapari. In doing so, it carves the Yarlung Tsangpo Grand Canyon. This is, by far, the longest and deepest canyon in the world. At over 500 kilometers long, and with an average depth of 2,268 meters, reaching over 6,000 meters at its deepest point, It makes the Grand Canyon in the United States look small in comparison. It is a true wonder of the natural world. This canyon is a place of immense natural power and biodiversity. The dramatic drop in elevation creates a huge range of climates within a very small area. At the top of the canyon walls, you find icy alpine conditions, while at the bottom, the climate can be subtropical. This unique environment supports a rich variety of plant and animal life, much of which is found nowhere else on Earth. The canyon is a vertical world, a sanctuary for rare species, and a place of breathtaking beauty. It is this untamed wilderness that the dam project seeks to conquer, a decision that has raised alarms among conservationists worldwide who fear for its fragile and unique ecosystem. The geology of this region is just as dramatic as its appearance. The Great Bend is located at the exact point where the Indian tectonic plate is crashing into the Eurasian plate. This colossal, slow-motion collision is what created the entire Himalayan mountain range. The land here is still being pushed upwards at a remarkable rate. Mount Namcha Barwa, for instance, is growing by about 6 centimeters every year. This constant geological movement makes the region incredibly unstable. It is a land of shifting mountains, frequent rockfalls, and powerful forces that are constantly reshaping the landscape. Building a massive dam and long tunnels here is an unprecedented challenge. For these reasons, the Great Bend has long remained one of the planet's last unexplored frontiers. Its extreme terrain and powerful rapids have defeated explorers for generations. The full descent of the river through the canyon by kayak was only successfully completed for the first time in 2002. This is a place that has resisted human conquest. The decision to build a mega dam here is therefore a profound statement. It represents a belief that modern technology can overcome even the most formidable natural obstacles. But it also means placing a monumental human structure in a place defined by its raw, untamable, and ever-changing power. Once the Yarlung Changpo crosses the border into India, it becomes the Brahmaputra, a river that is the heart and soul of the nation's northeast. Here, it is no longer a narrow canyon river, but a vast, sprawling waterway that nourishes the plains of Assam. This river supports the lives and livelihoods of nearly 130 million people in India alone. It irrigates an estimated 6 million hectares of fertile farmland, allowing farmers to grow rice and other essential crops. The annual floods, while sometimes destructive, also deposit nutrient-rich silt that has kept these lands productive for centuries. The Brahmaputra is a giver of life, and any change to its flow is a matter of profound concern. Further south, the river enters Bangladesh, where it is known as the Jamuna. For Bangladesh, a low-lying delta country, this river is even more critical. The river system of which the Jamuna is a major part provides over 65% of the country's entire freshwater supply. Agriculture, the backbone of the Bangladeshi economy, depends almost completely on this water. The dam in China could have devastating effects here. If it blocks the flow of the nutrient-rich sediments that the river carries, it could slowly starve the delta's farmlands, reducing their fertility. This would be a disaster for a nation that struggles to feed its large population. The impact would also be felt by the millions who depend on the river for fish. An estimated 2 million fishermen in India and Bangladesh make their living from this river system. The fish they catch are a vital source of protein and income for countless communities. A dam can block fish migration routes, and changes in water flow and temperature can destroy their breeding grounds. A reduction in the fish population would have a direct and immediate impact on the poorest people living along the riverbanks, taking away their primary source of food and livelihood. The health of the river is directly tied to the health and prosperity of these communities. Beyond farming and fishing, there is the risk of increased riverbank erosion. The dam could alter the river's natural rhythm of flooding and sediment deposition. This could make the riverbanks in Bangladesh more unstable, leading to more land being lost to the water. In a country where land is already scarce, every square meter is precious. A 2022 report from Bangladesh's own government warned that even a 5% reduction in the river's flow could cause a 15% drop in agricultural output in some regions. For the people of India and Bangladesh, the river is not just a line on a map. It is their lifeline, and they fear it is now in another country's hands. The plan to dam the Yarlung Tsangpo has created more than just environmental concerns. It has sparked serious geopolitical tensions. One of the biggest problems is that there is no water-sharing treaty between China, India, and Bangladesh for this river. International law often requires countries to consult and cooperate on projects that affect shared water resources. However, in this case, China is moving forward with its plans without a formal agreement with the downstream nations who will be most affected. This lack of communication and cooperation has created an atmosphere of mistrust and suspicion among these powerful neighbors. For India, the dam's location is particularly worrying. It is being built very close to the disputed border region of Arunachal Pradesh, which India governs but China claims as part of South Tibet. China's massive infrastructure project in this sensitive area is seen by India as a way for Beijing to strengthen its military and civilian presence, giving it a strategic advantage. India fears that the dam could be used as a political weapon. In a time of conflict, China could theoretically hold back water to create a drought downstream, or release a massive amount of water to cause devastating floods. The dam gives the upstream country tremendous leverage. In response to China's announcement, India has declared its own plans to build a retaliatory dam. Shortly after China revealed its project in 2020, India announced it would construct a large dam on the Siang River, which is the main artery of the Brahmaputra as it enters India. This dam, costing an estimated $1.2 billion, would be India's largest. Its purpose would be to create a large reservoir of its own. This would help India manage and offset any sudden changes in water flow from China's dam, giving it a buffer against potential water manipulation. This move signals the start of a dam race, where countries build competing projects out of fear and mistrust. This situation highlights a growing challenge in the 21st century: water politics. As populations grow and climate change makes water resources less predictable, competition over shared rivers is becoming a major source of international conflict. The Yarlung Tsangpo Brahmaputra River is a prime example. Without treaties, transparency, and a shared commitment to managing the river for the benefit of all, the dam could become a permanent source of friction between three of Asia's most populous nations. The ripples from this single project could destabilize a region that is already home to complex political disputes. Building such a colossal structure in this part of the world is not just an engineering challenge. It is a gamble with some of the most powerful forces on Earth. The dam is located in one of the most tectonically active regions on the planet. As mentioned, this is where the Indian plate is colliding with the Eurasian plate. This continuous geological battle makes the area extremely prone to earthquakes. History shows just how dangerous this region is. In 1950, a massive earthquake with a magnitude of 8.6 struck just 200 kilometers away from the proposed dam site. The ground shook so violently that it changed the course of rivers and caused widespread destruction. The risk of a major earthquake is not a distant possibility. It is a statistical certainty. Since 1901, scientists have recorded over 4,000 earthquakes with a magnitude of 4.5 or higher in this region. Placing a dam that holds back billions of tons of water in such a place is a terrifying prospect. If a strong earthquake were to damage or break the dam, it would release an inland tsunami of unimaginable force. A wall of water would rush down the canyon and into the plains of India and Bangladesh, wiping out everything in its path. The sheer weight of the water in the reservoir itself can also put stress on fault lines, a phenomenon known as reservoir-induced seismicity, potentially making earthquakes more likely. Beyond earthquakes, the mountains themselves are unstable. The steep canyon walls are prone to massive landslides and avalanches. The constant uplift and erosion create a landscape that is always in motion. The construction process itself, involving extensive blasting and excavation, could destabilize the surrounding slopes, triggering catastrophic landslides. Furthermore, the tunnels being drilled beneath Mount Namcha Barwa face a unique risk. The mountain is actively growing, rising by several centimeters each year. Over the lifetime of the dam, this uplift could deform, bend, or even crush the tunnels, leading to a catastrophic failure. The ground is literally moving beneath the project. These geological risks make the Yarlung Changpo Dam one of the most hazardous engineering projects ever attempted. While modern engineering can account for many things, the sheer power and unpredictability of nature in this region present a challenge on a completely different level. Engineers must design a structure that can withstand not only the pressure of the water behind it, but also the immense and continuous forces of a planet in motion. The potential for a disaster of biblical proportions, whether from a quake, a landslide, or geological shifting, hangs over this project, a stark reminder of the limits of human control. So, why is China willing to take such enormous financial, political, and geological risks? The answer lies in the country's urgent need for clean energy. China is the world's largest consumer of energy, and for decades its rapid industrial growth has been powered primarily by coal. This has made China the world's biggest emitter of carbon dioxide, the main greenhouse gas driving climate change. The pollution from burning coal has also created severe air quality problems in its major cities, affecting the health of millions. The Chinese government has therefore made a firm commitment to change its energy sources. This project is a cornerstone of China's ambitious climate goals. The nation has pledged to reach its peak carbon emissions by the year 2030 and to achieve carbon neutrality, meaning it will absorb as much carbon as it emits, by 2060. To meet these targets, China must rapidly transition away from fossil fuels and towards renewable energy sources like wind, solar, and hydropower. Hydropower, the energy generated from moving water, is a particularly attractive option. It is powerful, reliable, and does not produce greenhouse gases. The Tibetan Plateau, with its high altitude and mighty rivers, holds about 30% of China's total hydropower potential, and almost all of it remains untapped. The Yarlung Tsangpo Megadam is seen as the crown jewel of this green energy strategy. With its ability to generate 3 times the power of the Three Gorges Dam, it would provide a massive boost to China's clean energy supply. The government sees it as a vital investment in a sustainable future, a way to power its economy without polluting the atmosphere. The project is scheduled to be operational by 2033, a timeline that aligns with its climate pledges. For Beijing, the dam is not just about power, it is about securing its energy independence, demonstrating its technological prowess, and positioning itself as a global leader in the fight against climate change. However, the remote location that gives the river its power also creates significant logistical hurdles. The electricity generated deep in the mountains of Tibet needs to be transported thousands of kilometers to the densely populated industrial centers of eastern China where it is most needed. This will require the construction of a vast network of ultra-high voltage transmission lines. another massive infrastructure project in itself. The entire undertaking, from building the dam in an isolated canyon to delivering its power across the country, is a monumental effort driven by China's quest to balance its immense energy needs with its environmental responsibilities. The story of the Yarlung Tsangpo Mega Dam is a story of great contrasts. On one hand, it represents a remarkable human achievement, a source of immense clean energy that could help combat climate change. The power it generates could fuel the growth of a nation and reduce reliance on polluting fossil fuels. In a world facing a climate crisis, the development of such a powerful renewable energy source has clear and undeniable benefits. It is a bold step towards a lower carbon future, showcasing the incredible potential of human ingenuity to harness the forces of nature for what is seen as the greater good. On the other hand, the project casts a long and dark shadow. It threatens the livelihoods of millions of people downstream in India and Bangladesh who depend on the river's natural, uninterrupted flow for their water, their food, and their very survival. It places a powerful tool of control in the hands of one nation, creating geopolitical tensions and a dangerous dam-building race in a sensitive region. The lack of international cooperation and the absence of a water-sharing treaty turn a shared natural resource into a source of potential conflict rather than collaboration. Furthermore, the dam is being built in one of the most geologically fragile and biodiverse places on Earth. The risks of a catastrophic failure due to an earthquake or a landslide are terrifyingly real, with the potential to cause a humanitarian disaster on an unprecedented scale. The project will also irreversibly alter one of the planet's last great wildernesses, the Yarlung Tsangpo Grand Canyon, with unknown consequences for its unique ecosystems. The pursuit of clean energy in one location could lead to environmental and social devastation in another. Ultimately, the Yarlung Tsangpo presents humanity with a profound choice. It forces us to ask difficult questions about progress, power, and responsibility. How do we balance the need for clean energy with the rights of people downstream? How do we weigh the benefits of a single project against the risks it poses to millions? As this mega dam moves from plan to reality, the future of this great Asian river and the people who depend on it hangs in the balance. The only path forward that offers any hope is one of dialogue, transparency, and a shared sense of stewardship for the mighty river that connects these nations.